Ladies and gentlemen, welcome to the next episode of Printed and Organic Electronics Insights, featured by Innovation Lab. In the beginning, I have promised that some of the episodes will be more entertaining, some will be more informative, and today the focus will lie on the latter. In the last episode, we have demonstrated that our black magic foil here is able to identify different objects and differentiate between them. And today we want to give insights into the principle behind that and to the technology by addressing the question, how does this actually work? Therefore, we have invited Sylwester from innoplexia again. Sylwester, it's a pleasure to have you. Hello.
Hello, Florian. It's nice to see you in the second episode.
Nice to see you again. So, could you explain to us, how does this actually work?
We classify objects using deep learning, or maybe more correctly, using artificial neural network with deep learning architecture. This architecture was inspired by a visual cortex of animals and is especially suitable for the environment perception.
Aha, so this is really interesting, thank you. But I mean, everybody's using these buzzwords, artificial intelligence, machine learning, deep learning, pattern analysis, but nobody really knows what it actually means. At least I don't, so maybe you can comment on the differences between these words.
Nowadays, those terms are used interchangeably, but they represent historical development of the field. The broadest concept is artificial intelligence, and machine learning and neural networks are specific algorithms that are used in this field. The newest is deep learning. The term was coined a few years ago, and it changed the way we think about the neural networks. Before, we were trying to model the individual neuron as closely as possible, leaving the network itself relatively simple, with only one hidden layer. Now it is opposite. The individual neuron is relatively simple, and the whole complexity is implemented in the network. The network architecture is inspired by the visual cortex of animal, with many layers, and hence the name deep learning. Welcome to innoplexia. Let's go to my office. Let's look at the diagram of the network. We see a number of layers, and the information is processed from left to right, layer by layer. Each neuron takes the information from a few neurons from the preceding layer, consolidate the information, and send it to the next layer. We can also see that each layer had less and less neurons. The first layer is perceptron, which takes the information directly from the sensor, and the last layer have two neurons which fire when particular object is recognized, cola or water. The layers in between are hidden layers. The first hidden layer discovers the edges, and the second hidden layer discovers the corners when two edges from the preceding layer are crossing, and so up to the final classification of the objects.
All right, that makes sense, now I understand. But what I still wonder is, how does the system actually recognize that the Coke is a Coke? Because I mean, the system is intelligent, but it has no knowledge. It has to learn, right?
You are right, Florian. Developing the network is only half of the job. The other half is to train it with the data. While collecting and labeling the data, it is important to stay as realistic as possible. In our case, we have to press the bottles differently, we have to rotate them, and also take the background, for example, fingers and elbows, like in the normal warehouse. The story of artificial intelligence is very similar to the historical development of the airplanes. At the beginning, people tried to imitate the birds as closely as possible. But with growing understanding of the aerodynamics, the planes got the architecture they currently have. With artificial intelligence, it's very similar. At the beginning, we are trying to imitate biological neurons as closely as possible. Now, we are imitating visual cortex of the animals. But with growing understanding how the network processes information, the similarities are getting smaller and smaller.
Great, so this was really interesting. At least I have learned how this system actually worked, and I'm really curious about the future development. I hope you liked it as well. So the next episode will be about one of our most important research projects. Until then, stay tuned. Bye.
Bye.